let's do some revision. We need something with the calculator on hand. So we're just going back to how we dealt with trig before, I guess, recalling some of that. In the first example, we're finding an unknown angle. So we use our trig identity. We use our trig identity sin theta equals opposite over hypotenuse. We rearrange to get theta by itself. We sub in known values and we get theta equals 41.81 degrees. We have to use degrees and radians now because we know about both of those. In the second example, we are given a hypotenuse and an angle, and we need to find both our opposite and our adjacent. Which side is our opposite? Y. So I should start with sin theta equals opposite over hypotenuse. Sub in what I know, sin theta, sin 30 equals opposite y over 1 times both sides by 1 if I need, or I can just y equals sin 30, which let me guess is 1 over 2. The same applies for cos theta. So cos theta equals adjacent over hypotenuse, which equals cos 30 over, x over 1. X equals cos 30, which equals 0.866. Correct? Or root 3 on 2. Which is what it should be. Yeah, if that's not a party trick, I don't know what is. But you should know this party trick by the end of the week. If you listen and pay attention. For the trig ratios, all I'm asking us to do is recall SOHCAHTOA here, really. What do I need to think about when I'm using SOHCAHTOA? If I did not have this piece of information, could I use SOHCAHTOA? It's all relative to the angle, correct? I need the side opposite the angle, so I need that angle. Because if it was this side, this angle here, what's my opposite? Is it A or is it B? In this case though, we've got, what's the opposite? A. So sin theta equals A over C. Cos theta equals B over C. And tan theta equals A over B. Now I've asked this because we don't get much opportunity to do proofs. I have given us an opportunity to prove something that we may or may not know is true. Good part about this is if we ever forget, we can use this to remember. Tan theta equals opposite over adjacent, or A on B, correct? Yep. And that should equal sin theta, which is A on C, divided by cos theta, which is B on C, correct? What's the rule for dividing fractions?
Flip it.
Yep, keep change flip or flip it. So we get A on B equals A on C times C on B. The C's will cancel. We'll be left with A on B equals A on B. LHS equals RHS, which means that tan theta does equal sin theta on cos theta. Yep, just for those of us who like that. Cool? So that's a little recap on trig. Little touch on our proofs. Now we are going to need to know this thing here. This is something we need to know. So keep that in the memory bank. Keep obviously the opposite and the adjacent and the hypotenuse in the memory bank. But be aware that where we've used trig in the past is only a very small fraction of where we can use it. And it actually probably isn't where it's most applicable. I don't want to get bogged down in where it's applicable. What I want to do is get us to understand what trig is and get us to understand why it's useful. This is something you're going to see over and over and over again. It's called the unit circle. You'll never guess why it's called the unit circle. Number one, it's a circle.
Does it have units?
Well, the unit, what does that mean? If you've got a unit, you have one. So you'll never guess what we need to know about this circle. The radius is 1. So all around this circle, the radius is 1. Even though my example doesn't look particularly 1-ish there, imagine I could draw. What does that mean this point here is equal to? The coordinate is 1, 0, correct? What about this coordinate here? 0, 1. What about this coordinate here? Negative 1, 0. What about the bottom coordinate? 0, negative 1. You need to know that. Shock horror. What am I missing on this? What have I drawn? What's that big plus sign? It's not the Swiss flag. It's a Cartesian plane, so I should have x and y, correct? Now what I want you to do, in your book, anywhere in your book, I want you to put a dot in the first quarter, somewhere upon that circle. So put a dot on the line, somewhere on the circumference of that circle. So I'm just going to put mine here. And with the ruler, I want you to connect that dot to the middle of the circle. Like so. Now what we're going to do is link what we've used for trigonometry in the past to where it's actually useful going forward. Well, it's still useful where we've used it in the past, but we're going to start expanding some uses. We're going to put a right angle triangle in, like so. I'm going to put theta there. What else do I know about this triangle? My hypotenuse is equal to? 1. What's this point here? Do we know what this point is yet? But how would we normally represent our coordinate? We represent it with an x and a y, correct? So there's some coordinate x and y. Everyone's got a different x and y coordinate on their book because we've all picked a different point. I'm missing one other piece of information I can mention. Right angle, correct? What can you tell me about this length here? What is that equal to? Is that length here any different to that length there? Are they the same length? So is the x coordinate equal to that length there? So can I call that length x?
Yes.
Good, I can. Can I call this length? What do you reckon I should call that? Y. Very good. Now I'm just going to take those arrows away so we get a little bit less confused. If I zoom in, I'm just going to draw this triangle again, but I'm going to draw it nice and big here. So this is my triangle. It looks something like this. I've got theta, I've got y, I've got x, and I've got 1, correct? So I'm going to ask you again, can you tell me the y coordinate? Can you tell me right now with definity what the y coordinate is? Yes or no? No, you can't. How much more information do you need to know? One piece of information. What's the piece of information we need?
An angle.
Some say x.
It could be an angle.
Could be either, correct?
Yeah.
One piece of information lets me know both within one step. What's that piece of information? The angle, correct? If I know the angle, I can find everything else out about that triangle. So what I want you to do is imagine we have an angle. I want you to get as far into the equation as possible. I want you to give me y equals something and x equals something. Go as far as you can, where all I need to do is sub an angle into my value at the next step. So I want you to get to a line where you've got y equals blood, x equals blood, and the only thing you need to do is sub an angle in. So let's see how you go.